Hello everyone, welcome to Designfusion YouTube video channel. My name is Sanket Patel and I am an application specialist at Designfusion. This is the part 2 of nonlinear plastic analysis, where we will apply load constraint and then after we solve our simulation model and we will review the result of our nonlinear analysis. In part 1 we have defined our problem and considered this RAM as rigid, and we prepare our geometry and created our FEM model. Right now we are in a FEM environment, so to apply load and boundary condition, let's move to the simulation environment where we can create constraint and apply the load and also define other boundary conditions. So in this case my first constraint would be on this node, so I will apply here enforcement displacement. I need to move this RAM downward z direction and the displacement will change with respect to time. So I have defined my end time is 3 seconds, and here the independent variable would be the time and dependent would be the length. So at 0 second my RAM at resting position, at 1 second it moved downward 25 millimeter, and second it will also move further downward, and at 3 seconds it will come back to its original position. So once I define the value of degree of freedom 3, all other degree of freedom would be the 0 because I need to restrict those degree of freedom for that node. This way I can define that this RAM is moving downward. The another thing is that I need to fix this bracket, so I can quickly use a fixed constraint where I can rapidly select the end edge of this bracket. In this case it would be this 2 edge, and I have selected that, and you can right away define your constraint that this bracket is fixed at that two end. Another thing is that I need to apply a contact condition or a definition between these two objects. For the better visualization, I hide the meshes. Next thing is that I will use a surface to surface contact definition to define the contact. Automatic pairing will help you to create n number of contacts at a single time, but in this case I only have one contact, so I will use a manual method where I selected the RAM and the bottom face of the RAM would be contact with the top face of this bracket. After deformation, this plane would be also in contact with the RAM, so I have selected that also, and here I have created my contact definition very easily and rapidly with least effort. So once I define my contact, we can quickly solve our simulation. So Simcenter created input file and dock into the next run, and it is solving right now. You can also review the result using a solution control monitor and you can visualize it. In this case I need to visualize displacement magnitude, so I have called that, and you can see that as simulation progressing, this RAM is deforming our bracket. Moreover, to check the feasibility of your solving process, you can take a closer look of this plastic strain graph, and you can also check that how many nodes are in contact. Moreover, you can also check conversion criteria and process of convergence. So here you can see that our conversion criteria is matching, and this graph will help you to know that number of iteration required to solve one time step. I will pause the video. My simulation is solved now, so here you can see that we have deformed bracket and our simulation is done, and we do not get any error messages. So we can tell that everything is good. Let's close this information window and let's result and review the result. Here you can see that I have a 30 increment, so I need to know the displacement result first. For better visualization, I will hide this 1D mesh and let's use this arrow to review our iterations. So you can see that we can review that using that arrow, or if you want to animate throughout the iteration, you can easily animate it. Here we have the nice animation of our deformation process. Another thing that this nonlinear analysis context is more important, so I need to check that how my context is going on throughout the simulation. So I need to know my contact force so I can review it, and same way I can animate it throughout the iteration. So here you can see that everything's look good. So as our ultimate goal was to know that how much plastic strain will develop once my bracket will plastically deform, so you can right away review your plastic strain result as well. Initially it is about 0. As it progress, RAM move downward, it is deforming the bracket and our plastic strain is increasing as RAM is going downward. And here you can see that some area has plastic strain, so it will remain the shape of the bracket as it is because it plastically deformed. So this way in Simcenter 3D you can easily and very quickly create your nonlinear plastic analysis and solve it. And using most advanced post-processing tool, you can review your result in detail. For more video, please like and subscribe our YouTube video channel. Thank you.